We've all been there, glued to the screen as a hero bravely attempts to save humanity from a catastrophic asteroid impact. Hollywood loves a good disaster flick, and asteroids have become a staple threat to Earth in our collective cinematic imagination. But what about real life? Could we actually blow up an asteroid if it was hurtling toward our planet? The answer, as with most things in science, is more complicated than a simple yes or no. Scientists and engineers are actively working on planetary defense strategies to protect our pale blue dot from these cosmic interlopers. From kinetic impactors to gravity tractors, the field of asteroid deflection is brimming with innovative ideas. Blowing up an asteroid isn't about creating a spectacular explosion like in the movies, it's about altering the asteroid's trajectory to miss Earth. One option is a nuclear explosive device. A nuclear blast could vaporize part of its surface, pushing the asteroid off course. Another method is the kinetic impactor. This involves slamming a spacecraft into the asteroid to change its path. Or, there's the gravity tractor. A spacecraft uses its gravity to gently tug the asteroid off course. While the idea of nuking an asteroid might seem like a quick and dirty solution, it's crucial to consider the potential consequences, both positive and negative. On the plus side, a nuclear explosion could be a viable option for deflecting large asteroids, especially if we have limited time to react. The immense energy released could significantly alter the asteroid's trajectory, potentially averting a catastrophic impact. However, the use of nuclear weapons in space is a highly sensitive issue, fraught with ethical and political complexities. There's also the risk of creating a shower of smaller radioactive fragments that could still pose a threat to Earth. Imagine instead of one large impact, we end up with a cosmic shotgun blast. Not ideal. Furthermore, the effectiveness of a nuclear detonation depends on various factors, including the asteroid's composition, size, and spin. A poorly executed blast could fragment the asteroid into unpredictable pieces, making the situation even worse. The question of whether or not to blow up an asteroid has sparked heated debates within the scientific community. Some experts argue that nuclear weapons are a necessary last resort, while others believe that non-nuclear methods, such as kinetic impactors and gravity tractors, are safer and more controllable options. Those in favor of nuclear deflection emphasize the urgency of the situation, arguing that we may not have the luxury of time to employ slower methods like gravity tractors. They point to the potential devastation of an asteroid impact and the need to have all options on the table. On the other hand, critics of nuclear deflection highlight the risks of radioactive fallout and the potential for creating more hazardous space debris. They advocate for investing in early detection systems and developing non-nuclear deflection technologies that offer greater control and precision. The debate ultimately boils down to a complex risk-benefit analysis, weighing the potential consequences of inaction against the potential unintended consequences of our actions. Section 5. A cosmic game of billiards, the uncertain aftermath. Even if we successfully deflect an asteroid, the story doesn't end there. The aftermath of an asteroid deflection attempt could present its own set of challenges and uncertainties. For instance, a slight miscalculation in the deflection angle could send the asteroid on a new trajectory that intersects with Earth's orbit in the future. It's like playing a cosmic game of billiards where a poorly aimed shot could send the 8-ball careening into the wrong pocket. Moreover, fragmenting a large asteroid into smaller pieces might seem like a good idea, but it could create a swarm of smaller projectiles that could still pose a threat to Earth. It's the difference between being hit by a cannonball and being peppered with buckshot. Then there's the issue of space debris. The debris from a shattered asteroid or the remnants of a nuclear explosion could add to the growing cloud of junk orbiting our planet, posing a hazard to satellites and future space missions. Section 6. Planetary defense, a global imperative. Protecting our planet from asteroid impacts is not the sole responsibility of one nation, but a global imperative that requires international cooperation and collaboration. Just as nations have come together to address global challenges like climate change and pandemics, we must forge a united front to tackle the threat of near-Earth objects. This includes sharing information, pooling resources, and developing coordinated response plans. International organizations like the United Nations Office for Outer Space Affairs, or UNUSA, play a crucial role in fostering dialogue and cooperation on space security matters, including planetary defense. By working together, we can leverage our collective knowledge and capabilities to safeguard our planet for future generations. Section 7. The power of early detection. Time is our ally. In the game of cosmic defense, early detection is our greatest asset. The sooner we identify a potentially hazardous asteroid, the more time we have to develop and implement a deflection strategy. Astronomers around the world are constantly scanning the skies, searching for near-Earth objects. Telescopes equipped with advanced sensors and sophisticated software are used to track these celestial objects and calculate their trajectories. The key is to identify potential threats years, if not decades, in advance. This lead time allows us to carefully study the asteroid, determine its composition, size, and spin, and develop a tailored deflection plan. Section 8. International cooperation, a united front. The threat of asteroid impacts transcends national borders, making international cooperation not just desirable, but essential. No single nation possesses all the resources, expertise, and technological capabilities required for a comprehensive planetary defense system. Sharing data from telescopes and early warning systems is crucial for creating a robust global network that can detect and track potentially hazardous asteroids. Pooling resources for developing and deploying deflection technologies can significantly enhance our chances of success. Moreover, establishing clear protocols and lines of communication among nations is essential for coordinating a timely and effective response in the event of an impending impact. A coordinated global effort is not just about sharing the burden, but also about leveraging the collective wisdom and capabilities of humanity. Section 9. Investing in our future. The cost of cosmic security. Protecting our planet from asteroid impacts requires a sustained commitment to funding research, developing technologies, and deploying planetary defense systems. While the cost of such endeavors might seem substantial, it pales in comparison to the potential devastation of an unmitigated impact. Investing in planetary defense is not just about averting disaster, but also about investing in our future. It's about ensuring that future generations inherit a planet that is safe from cosmic threats. It's about fulfilling our responsibility as stewards of Earth. Moreover, the technologies developed for planetary defense can have spin-off benefits in other areas, such as space exploration, resource mining, and understanding the origins of our solar system. Section 10. The ethical dilemma, our place in the cosmos. The prospect of deflecting an asteroid raises profound ethical questions about our place in the cosmos and our responsibility to protect our planet. Do we have the right to interfere with the natural trajectory of celestial objects, even if it's in the name of self-preservation? Some argue that we have a moral obligation to protect all life on Earth, and that deflecting an asteroid is a justifiable act of self-defense. Others caution against tampering with the natural order of the universe, warning of unintended consequences that could be worse than the threat we're trying to avert. The ethical debate surrounding asteroid deflection underscores the need for careful consideration, open dialogue, and a deep understanding of the potential consequences of our actions. It's a debate that will likely continue as we develop the technological capabilities to alter the course of celestial objects. Section 11. The conversation continues, looking up and moving forward. The question of what to do about asteroids on a collision course with Earth is one that will continue to challenge and inspire us. It's a question that compels us to look up at the cosmos with a mixture of awe and apprehension, recognizing both the beauty and the potential dangers that lurk in the vast expanse of space. As we continue to explore the universe and unravel its mysteries, we must also remain vigilant about the threats that exist closer to home. By investing in research, developing technologies, and fostering international cooperation, we can build a robust planetary defense system that will safeguard our planet for generations to come. The conversation about asteroid deflection is just beginning. It's a conversation that requires the collective wisdom of scientists, engineers, policymakers, and the public. It's a conversation that will shape the future of our relationship with the cosmos. Let's keep looking up, keep exploring, and keep working together to ensure that our pale blue dot remains a safe haven for life in the vast universe.